Hi everybody, this is Group 8's PowerPoint reviewing our design and assembly of our vertical axis wind turbine. Andrew started us off by creating the SolidWorks design and then by 3D printing these pieces for our final assembly. Shreya did an overall evaluation of the turbine and assessed what could be changed for future improvement. Nick did a cost analysis of our final prototype and will let you know our final design's value. Raul did a prediction analysis of the overall power and efficiency ratings. And finally, Sabrina did an overall design review and justified the makeup of our turbine.
Our design was easy to put together and effective. Blades were in shape of hollow semicircles and were made out of cardboard and sheet metal. It was a simple assembly which consisted of 3D printed connectors which held the blades together, nuts and bolts which connected the blades on the rod, a spinning rod which helped the entire turbine rotate, and a base which supported and rotated the pole.
The assembly of our wind turbine was relatively simple, with the circular gasket being just the right size to stay on the center rod without an additional fastener required for it to stay in place. The center gasket has 3 connecting pieces that come out of it, each being secured to the center gasket with nuts and bolts. Each of the 3 connecting pieces have a blade attached at an angle for maximum surface area, with each blade being connected to the connecting pieces with nuts and bolts. All of the parts are shown here individually, including the center rod and the wooden base block. The center gasket and connecting pieces were 3D printed, with the blades being made from a combination of cardboard, foam board, and sheet metal.
After testing our wind turbine in the Frith lab, we obtained the following data. Our efficiency rate was 0.34775% and was calculated from the power formula: power is equal to half into density into area into velocity cube into efficiency, while using the voltage and resistance datasets generated during testing to find power. From our actual power versus efficiency graph, both variables had a positively proportional relationship. However, from our calculated predicted power, our generated power was much lower.
After evaluating our decision matrix, we decided to go with the semicircle design, which scored high in the simplicity, weight, effectiveness, and efficiency categories. The semicircular blades were chosen not only because of their ease, but also their aesthetics. They made the turbine easy to assemble and also more effective in utilizing wind power. In our primary prototype, we had 4 blades attached to the metal pole. However, we decided that in order to generate maximum power and energy, 3 blades would be suitable for the final design. The 3 blades also led to an easier assembly and a lighter overall mass. We lined each blade with sheet metal, which added structure and stability to the wind turbine while also adding aesthetics. Foam board semicircles were placed at the bottom of each blade, adding structure and also acting as a device for attaching the blade to the pole. Although our design was not the most intricate, it was lightweight, simple, easy to assemble, and overall effective when it comes to generating energy.
So the total cost for one unit of our wind turbine was $53.70. We arrived at that number by looking for standard units of cardboard, sheet metal, metal rods, and foam pieces, and their current retail price across several reputable sources such as HomeDepot.com, Lowe's, and Amazon. For the screws, nuts, and super glue, we also looked at common retail prices for these items, and that was used to generate the prices. For the 3D printed pieces on our wind turbine, we looked at the price for printing in the Frith lab, and that price can be calculated based on the area of our printed pieces. So we were able to find that each connection piece on our wind turbine would cost $3.55 per piece. We had 3 of those, so that's going to come out to be $10.65 for our connecting pieces. And then for our one circular piece, that came out to be $8.85.
While our turbine was easy to use and effective, some future improvements to be considered are making the turbine more aesthetic, having better, sturdier material, which would make more effective to harness more wind. Make the rod and the base one piece, which would prevent the two from getting disconnected all the time. Making the connector and the rod the same diameter so the entire turbine could be easier to use.